Hello and welcome back to another evening of Rust. I just quickly adjust my camera, I'm a bit far down. Today we'll be going back and doing Smash the Code again. It's something we started yesterday. For those of you new to the show, we are doing Rust programming for AI bots on the site called Coding Game. And I just close these random things that pop up. And Euler is already pointing out something I whined about yesterday. So we started with the most simulation theme game of all, and we're going to cry about performance, and he's absolutely correct. And I'm going to repeat what we did yesterday, and I'm going to tell you exactly why that is. Somebody recommended this game to me, and it has a Tetris theme, or it has like the battle Tetris or blocks, whatever you want. And I used to love playing these games, so I thought, hey, let's do this one. And it uses a matrix, and there's only so many possibilities, but Euler Schützel is absolutely correct. We have a performance problem, but let's join in and see where we are already. As usual, if you have any questions, please give me a shout, whether it's about Rust or the coding or AI or anything in general, just feel free. Or feel free to just watch the show and enjoy my complaining about what I don't know what I'm doing. So the game is, and we're at rank 880, we changed something, we were higher before. The game is very simple. Let me play around against the computer, and you can see what it is, because to get rid of the title here. We have a Tetris game, and as we get larger combos, we do more damage to the enemy. And so our playing here, we do some weird setup, and we hit the guy, and our setup isn't very good. And as you get combos, you shoot at the guy, but we're not getting very good combos. You watch, he gets really good combos, and he shoots us. So there's a couple ways you can play this game. Right now, the way we're playing the game is very, very simple. I have an algorithm that drops them in a few different columns based on what's already in the column, and it's really trivial. It's just the height of the column. And then I do a really simple simulation, a one-step simulation to check these combinations of which one gives me a better combination. And it's not even good enough to beat the Wood League. And we've seen in the other competitions that the Wood League is usually not that strong, but in this one, it's an older one. They must have had other rules, that this is way beyond what we've ever had to do for Wood League before. We actually have to do strategy. Now, I've opened up Octave to show you the next thing, is that what Euler is pointing out is that there's another way to play this game. And let me back up here just a little bit to show you an idea. If you see the purple piece in the middle here, we have an option. We can put this in any one of the 6 columns here. We can also rotate it one of 4 ways. If the 2 colors are the same, it's only 2 of them make any difference, okay? But there are 4 ways, and so that means for any piece, we have 6 positions times 4 rotations. Now, that repeats for each of these next pieces. So we have another 7 pieces, we have 8 pieces in total. And the reason I'm doing this calculation is that given the current setup, given the current number of items in the screen, whoa, I think that's actually way too high. It's not what I wanted to do. This is just times 8. Times 8, that's actually not even true. It really is to the power of 8, isn't it? Yeah, okay. So that's the total number of combinations, and we totally did that wrong last time. I did times 8. No. What did I even do last time? I think I just did 6 to the 8th as initial calculation. Something like that. What anyways, these numbers are all way too big anyways. What these numbers mean are the number of ways if we wanted to evaluate all the possibilities. So we take this whole stream of items and dump them all in here, and all the combinations that we have, how many different possibilities could we actually have given these 8 set of pieces? The reason we'd want to calculate that is because if we can calculate all those possibilities and give them all a score, well, then it's very logical to figure out where we put the purple one. We put the purple one that gives us the highest score. But the issue is this number, and we had a number of 321,000 yesterday, so I have no idea how we got there. I've calculated something wrong now, but in any case, I think it's 6 times 48 because every piece has a unique position, and there's 24 possibility options for each piece to the power of 8. That's the number of combinations. There's no way you're going to get through all that combinations. The game has a time limit, but we don't even have to worry about it. So we have 100 milliseconds per turn. Now, in normal computing terms, 100 milliseconds is a very long time. And alright, I'm being corrected on that. 22 days. Alright, that's correct. We can't so that's the correct ball. Euler's law has the correct amount there, 22 d8. So it's slightly lower than 6 times 48. That difference is virtually irrelevant because, right, even if you can evaluate one move per turn, one move per nanosecond, per clock cycle, let's say you can move one move per clock cycle, you still can't actually evaluate all those moves with it. Still takes 54 seconds, and this is just not going to happen. So we have a lot of options in how to do this. The one we've been doing in the past is Monte Carlo tree search is a very common one, and they call it tree search, but really to simplify it is you just take the purple one and put it in one of the 6 columns, and then from there you randomly evaluate the rest of them a whole bunch of times, and you just see whichever ones they produce, and the one that produces the best value, you just take that one and say, let's go with that one. And it's called kind of a tree search for the idea that, you know, it is forming a tree of all possibilities, and what you're doing is pruning, and there are ways to optimize it for pruning. There are ways to evaluate it, drop tree branches, and evaluate certain branches more than others, and you could actually just start going 3 levels deep and then randomizing it out. So there are a lot of possibilities here. But now, if you've not seen the show before, then you're going to hear me complain about one big thing, and we actually open up the issue on Coding Game. And let me go to that. We actually have the issue there, and it has to do about debug mode. Now, we don't have a chance of doing any good on this code. If it is actually permutation based, and Euler's law is really indicating it is, then we're in trouble. Okay, so I brought this up here, and if anybody wants to go to this link, like it, reply to it, tell them that you want this here, and we have Thibaut. He's actually one of the community managers. He's going to try and push it up for it. As he says, he'll try to push it up for it. We need to get the games compiled in release mode, because right now they're being compiled in debug mode. So anybody that's done a lot of programming understands that debug mode is generally very slow. It's horribly slow. The problem with Rust is Rust uses a lot of high-level features for its normal operation, like iteration, mapping, filtering, and that makes it really, really bad in debug mode. And as I mentioned it in the quote here, 30 times longer. And that sets you up to like not even have a chance to do this stuff, because it's not just that it's 30 times longer, it's the type of operations that are that long. A lot of the stuff that should be free in release mode is costing us stuff. So it's actually far worse than 30 times mode. It's like really all the stuff that just shouldn't be there at all is costing us time. And we know from the last competition we did, which one was the last one we did? Hypersonic, that's the Bomberman one. We were able to in Bomberman, and Bomberman is a more complicated board, admittedly. It's a more complicated board, and there was a few more possibilities. But, actually there was less possibilities. Shit, yeah. Well, we only managed to get, like, even when we tuned stuff, a couple thousand evaluations. And that's not a bad thing, good thing. That was terrible. We just gave up on that one because we can't get further. There's no point in optimizing it because the type of optimizations we were doing were just silly. They didn't help us at all. So we have a couple options now. Knowing we can't evaluate the full tree, we have 2 options now that I can do on the show. I can either attempt to do the proper evaluation and live with the fact that we're going to have utter garbage, or just hope that we get further, or we can try a heuristic-based approach just to get us out of Wood League. Now, what I mean by a heuristic-based approach, and heuristics is generally a term we use, and to be honest, heuristics is a term you use when you don't have a name of another algorithm, okay? Let's just put it that way. And what it means is that we're going to do some logical scoring. We're going to put our mind into it. And our mind is going to look at stuff and decide, how do I do this stuff? How can I win this board? What is the board? And so what we would do is each move we would attempt to score the board. We look at the board and say, is this a good position? Do we know how much this board is worth? and then we'll decide just based on that. Whereas the Monte Carlo approach simply says, look, you don't have to think. You just go through all of these, punch them in, and see what score comes out. It's a fixed score system. What you can do is a combination of the systems, and I think, wondering if maybe we shouldn't do that approach. We set up the Monte Carlo, make it very shallow, and do a lot of pruning, and then maybe hope for the best that way. This is a definite option. We basically have the setup we need right now, and then we can look for that. So I'm a bit uncertain what we have to do. If I go the correct way, we're going to hit the time limit really, really fast, and that may not be too bad though. We may be okay with that. So let's just go that way. I mean, I don't have it. We got up to halfway before with the easy algorithm, but the computer opponent right now is clearly using something relevant. Maybe a one tree search depth might be just good enough. So let's just go for it. Let's start the searching, and I'm going to avoid calling it the Monte Carlo search from this point. Just imagine this belongs to that family of computations. There are some specific rules about what you would have to be to actually be legitimately Monte Carlo and stuff, and at this point we really don't care. We're just going to do some sort of tree searching evaluation on that, and whether we're doing sampling, tree searching, pruning is not relevant at this point. I just give you some terms to look up. So let's look at the code where we are from last time. I started with get best move. So in the entry is how we usually do this. We have the entry, we have the main loop. This parses in the input of the game, and it calls something called get best move, and then it outputs that best move. The move being which column and which rotation you have. Good. So we never need to touch entry again for now. I can close that. We don't need to touch it. Lib is also just some setup for Rust. Matrix is also, I keep looking at that. State is where we store the current state. And strat is where our strategy is, and there's this function called best get best move, where we give it the state, and I return which column and which rotation I want. It starts with saying this one, we return sum, and we built this return sum because I think the newest Rust has something that's built in that does this now, but we couldn't use it. There's some sort of question mark operator. I can't remember where. Well, let's just say what I'm doing. Return sum is saying that get best destroy move returns an option. It says if this option has a value in it, just return the unwrapped value of that. And so it creates this little shortcut. It is one of those nice shortcut features for working with optionals, and there are in newer Rust. I believe there's a syntax for that. If somebody knows it, please type it. I can't remember what it is. We can't use it yet because the version of Rust encoding game doesn't support it. Get destroy move, what we're looking for here is for every one of the columns, so 0 through 5, I attempt to put the item there without rotation, and I do that by applying a turn, and then I destroy the groups, and destroy the groups destroys all the things it destroys. And then we're looking for something called has drop, and this is something that I identified last time, that if there's something hanging, like if you can get anything, where do I have this? Right now, if you could drop a blue one down here and kill these blue ones, you'd have this red one hanging here with an empty spot. And that's a good position you want to be for combos, because that's what's make combos possible. For us, it's not turning out so well, but that's the idea behind it. If we destroyed stuff and it has a drop, we do it. And I try this for all 6 of the columns, and I take the one that just destroys something and go with it. I don't look for the best one or anything yet. And that's where we are now, and why I say we're set up for like a sampling or searching is that I have this apply turn function, and this is the key to it. This apply turn and this destroy groups. Destroy groups has to be expanded to have, maybe that'd be enough. I want to look for the one that destroys the most groups. And so what we can do is going down. I should really look at the camera, I think, but then it's weird that I'm thinking at the light. Is the light there? Okay. So to start the search, what I would do is I start with the first one, and then I do the second one and the third one, and let's just see how far down we can go. let's just set up the recursive search here first of all. And I'm going to do this by making this a bit wacky first of all. We're going to do a function get best move, and I'm just going to call this one 1. This is the old function and state. This gives me something to fall back to. And that would be called here. And get best move, we're just going to try a different one. Get best move search. I'll just call this one old. We're not going to call it. And I can mark it this way by saying I'm not going to call it. Get best move search state and state. And this destroy move goes away. So I'm going to set this up by saying, I don't even know if I need to know this here. Do we need the strategy? Yeah, we're going to put the strategy in here because I might want to update it. And I had that from the first coding game competition with the Borders of the Galaxy, that unfortunately in that game I didn't have immutable state. I didn't have any state at all in the strategy. I couldn't pass it in. And that made an issue that we wanted to update the state at some point. Here I can simply change these all to mutable at one point. And being able to track goals is really helpful. It just lets you track long-term things. If we get to it, we'll get to it. Otherwise, just ignore what I said. State and state. State. Okay. So we have a state and we know which other items we have on that board. And so I'm going to set up the recursion, and the top level recursion is always a little bit special because this is the one that collects the scores. Because the lower level recursion, it's evaluating scores, and the top level one saying, let's figure this one out. So for column, and we're going to go through all of the columns. And for each of these columns, I'm going to have to duplicate the state. This is virtually identical to the one below. I'll just talk about it first. And the turn is always going to be column, comma 3. And 3 is just one particular rotation. This is where, okay, no. Yeah, we're going to have to do this way. So now we have rotate in 0.3. There are 3 rotations. For each of these, you can already start seeing that the cost of state clone is a really big cost factor in how we do this. And so turn is rotate. And so for just the one purple one or the red one right now, there are 24 possibilities. Or as Euler says, there's not that many because one of them's not valid. And apply turn, I think, is going to say that for us. We're going to have to make apply turn check for validity. Yeah, apply turn actually retracts the validity. If apply turn fails, then we can just kill it. Okay, so it's a possibilities. So we do this, if not apply turn and mut-dup turn, then just continue. The not here being that it didn't apply right. We had the wrong thing. We did a rotation near the edge of the board, because if you're on the edge of the board, you can't rotate to be outside of it. And rather than try to detect in advance, we just apply it. And obviously there's a cost issue here, but it's a very minor one compared to what we're facing. So we apply the turn, and this sets up the basic one here. And what we want to do is we want to say best turn, and it's going to start as none. And let best score equal, I guess 0. Best score is 0. I'm going to adopt the strategy we had right below here first, just so we can see that it's working. Let destroyed equal destroyed groups, and then I'll change it later. Destroyed groups and mut-dup. If we don't already have a best turn, is none or destroyed is greater than best score. I'm just going to make that the score for now. We'll worry about that later. Then best turn is whatever our current turn is, and we update the score as well. Destroyed. And my phone messaging me if you hear the weird messages there. And Alright, what can I do now? I have, and then at the very end, I'm going to assume that we always have a best turn, because there's no way you can get through here and get no turn. It has to at least give one, and so I'll just do that. Get best search move. And this does essentially a one level depth, looking for the one that destroys the most. And if I did this correctly, this will actually prefer, what if I, this should put at least the columns together. Get best move search. Get best move search, and that's self. Alright, to get best move search requires two parameters. That is correct. It was like that. And I forgot to mark them that way. I'm going to get rid of this comment here for a bit, just so we don't have to worry about that. Best turn has to be mutable, and best score has to be mutable. Okay, and I forgot to submit it. I'm going to connect it to use our external editor. And oh no, it doesn't have a file. Well, that's interesting. Source/evening rust private. Again, if you're wondering why it's private, I've been asked by the guys at Coding Game that I shouldn't publish the code because it makes it too easy for people to come in and just submit the same code. And then you'd have a whole bunch of bots at whatever our level is. Obviously, wood level here is not really impressive, but on the ones where you make gold and legendary, it is an issue. So I don't submit the code, but if there's any utility code that you want, if there's any utility like matrix and stuff, just feel free to ask. I can post it to Twitter. And you're free to copy the equations and stuff as you see them. We're just trying to prevent people from copying and pasting the whole code and doing something. Alright, so that should give us enough. If I play now, let's see what happens. I'm expecting stuff to just stick over to the side. Yeah, and whenever there's a matching one, you can see we detect matching ones. So I definitely defined a match, and that's obviously not good enough. It's a very basic match because I'm looking one search level depth. But this just confirms that I do actually get matches. And yeah, we're going to lose. And I'm going to increase the speed of this again. Oh, it's a 2. Well, I don't think we need to see it. So clearly I lose this one. I mean, you can see right down here I lose, and you can see why, because I'm not getting any combos. So I'm going to go to the code and set up the next step there. And you got to... Oh yeah, okay. Now, the code actually did an unwrap, so there was a move we couldn't do. And this is totally fine, because what that basically happened is my board was filled. And I created an exception because there is no more valid move, but it really makes no difference. I've lost the game at this point anyway, so I don't have to worry about this situation very much. So I have the first level. Now let's go down and let's create the second level. This sets up the search. And now I'm going to do, how do I want to do this? I'm going to do iter best move search. And I give it a state again, and it's a state that can't be duplicated state. Now, actually, I want to do score best move. This returning a score here. I'm going to score the iter best move score. I'm going to say score now. Given a given move, how valuable was it just to make that move? And so this will give a score back, like I-32. And we want to have a depth here, a depth of I-32. And drink some water. And this is why the two loops are going to look very much similar, but we only do the one. And there's an option here that when we do this move, so I'm going to do the same basic thing here. Let's do this. And the score I'm actually going to convert right to F64 again, because scoring integer values is kind of silly. And this destroy group's now up here. Just to give you an idea what it was, it'll be iter best move score. And we'll self. And it takes the state, the duplicated state, and dupe. And it takes a depth of, say, let's just do 1 for now. No, let's do 2, so we at least go down to 2 double depths. And then it gets a score on a turn, and the score is an F64, 0.0 works the same. And this has to return a score now. And so all of these, we can accumulate a score. Let mut score equals 0.0. Let mut iterations. And now I'm just going to take the average of all of them. The average of them and see what happens. Average score. Although, and this is where it becomes very interesting with searching and sampling. It's how you combine the scores makes a big difference too. Do you take the average score? Do you take the maximum score? In some cases, it makes sense to take the minimum score, especially if that score involves losing. So we're just going to, this is an iteration count, is fine. I'm just going to take the average now. So I'm going to add them all up and then divide it. So we return score divided by iter. And you'll notice the duplication here again, every single step of the loop. So for every group width, we have to take this down. And I have to change something here as well. Actually, I'm going to do it differently. I'm just going to do it this way. And I'm going to do step count. And this is going to say which item to use. And apply turn is going to have to change. Apply turn is going to have to take the board item is doing, because I need to, for each step in the turn, I have to take this one, and this one, and this one, and this one, and I don't have any way to do that yet. So I'm going to have to set that up as well. And I should have done that first, because now I have all this code here that's... Yeah, I'm going to undo that first of all. Or not. I'll just go to apply turn. Well, I think I can simplify it. Apply turn. It takes a turn, and it takes a block count here, so I can actually do it this way. I can do apply turn and block index, and just give it this way, use size of block index, and then simply do it here, and that simplifies it a little bit for me, so I don't have to redo the turn. It's still all the same. So where's the apply turn? All the existing applied turns just apply block index 0. Oh, they don't need those. Those are turn apply blocks. Okay. Apply turn 0 and apply turn. This is where we do apply turn step. And this is increment, so that applies the next one. And then apply turn, turn, get destroy move, 0. That's the old strategy. Alright, that was easier than I thought it'd be if we do it that way. Best move, step, apply turn, step. If you can't apply the turn, then we continue. Otherwise, I'm going to have a finality condition here. If step is greater than or equal to 2, this is going to be our iteration depth now. So I'm not passing depth in, I'm testing it here. So if we have that depth, then we stop. Otherwise, we're going to keep going. And I'll move this up into it. And I'm going to make the score just the number that's destroyed. I don't check chain reactions, which is really kind of going to be an issue. I'm going to actually have to change the simulator to destroy groups. Actually then cleans it up and does it. So this is going to become a score function instead. And we should be okay with that though. Score plus equals destroyed as F64. and iter plus equals 1, one more. If we're not at the depth we wanted to go to, then I'm going to iterate there. Then I say score yeah, Euler, the chain reaction. Euler says it's chain reaction, and that's what I meant about checking the drops. Because right now I check one destroyed group, and that empties out the board. What I have to do is I actually then have to drop those things and then check it again. And that's exactly the chain reactions that I'm supposed to be looking for. So we only have part of the step now. Destroy groups only does the first step. I actually then have to check, clean up the board and check it again. And those things are worth a lot more. And that's the chain reaction that I'm looking for, because right now it's just going to be total things destroyed, and this is not valid scoring. But I want to set up the looping and the searching first, so then we can go look at the actual chain reactions next, but the chain reactions do have to come next. Score plus equals self.iter best move. And this is and doop. Have that and step plus 1. Iter plus equals 1 as well. In theory, this is enough that it should work with a very poor algorithm, though. What have I done here? This is supposed to be a state. That probably just screwed up the whole thing. I keep forgetting semicolons. I'm kind of surprised that Rust actually has semicolons. It's one of those things I was hoping would go away in modern languages. When I started using JavaScript without them, I really liked it, and my own language, Leaf, has no semicolons. You can use them if you want. They're there because sometimes you have to stick stuff in the same line, but generally you don't have semicolons, and it's extra syntax because any sane coding style has you have line ends anyways, and you can visually distinguish them. So it makes sense to get rid of them, but minor complaint. I have plenty of complaints about Rust, and that's not one that jumps up top of my list. Found I32, so this has to be a use size. Iter best move score, it should be. Enter best move score, what else do I have? And that was it. Alright, well, I go a couple deeper. Let's just hope I don't run out of time. That's the key one, because if I run out of time just on this depth, then really we might as well pack up the tent and go home, because there's no point whatsoever. Oh no. Oh no, what happened? Oh no, no, no. Well, now we have a problem. I got a timeout. That means that whatever algorithm we're using right now is so bad that I couldn't count down to a search depth of 2. And this is because it's a permutation. So now, and this kind of makes sense because I'm doing a permutation, and for the Monte Carlo we're going to have to do a random searching instead. Alright, so I'm going to change this to random searching. Instead of this, things get weird. I'm going to say while some condition, ... do this stuff inside here. So I can't do permutations. I have to do searching. And it's not... How do I want to do the searches? Do I want to go 8 depth down? Yeah, let's just do through the whole chain. Let's do an 8th depth search. We're going to apply all 8 of the things in a tree. So instead of do this for this doesn't really need a step anymore. I'm actually going to search down to the end of the game because that's all I have for step in 1 ... There's 8 things available to us. Magic numbers. Everybody loves magic numbers. I always get mad at people from using them in my interviews, but blocks count as 8, so I even have them. I don't need that. Blocks count. I only need to duplicate the state. Alright, sorry, there is actually a while loop out here as well. While condition, because we're going to do this many times. While condition. I hate visual code. I don't know why I keep using it, to be honest. It annoys me. I hate auto indentation. So inside here, we only have to duplicate the state in the outer loop. And for each of the turns, each of the duplications, what I can do is... And this is a little bit dangerous now with supply turn, because I should actually check if the turn is valid. Because otherwise I risk the chance that if any of the turns throughout the tree is invalid, I discard the whole tree, and that's not what I want. That'd be really bad. So, but I'll get to that. So what I do now is we have a column, and I need a random number generator now. And when was the last time we used one of those? We did that before. We did thread RMG. And this is another one, unfortunately, in Rust, in debug mode, thread RNG. The random number generators are pathetically slow. Well, that's interesting. And I'm just going to ignore that for now. Of course, the documentation I want doesn't exist, which kind of sucks. Let's see if the issue has some simple way of using it. Otherwise, I have to look through my code. I'm very bad at looking through my code to figure out where it is. And yeah, it has a very bad performance. When was the last time we used it? I did the thread random number generators for... What was the last one I did? That wasn't Tic-Tac, no, it was Tic-Tac-Toe maybe. Predict, did it have it? RNG? No. I thought it did. Strategy. RNG, no. No, it wasn't Tic-Tac-Toe. I'm positive it was Tic-Tac-Toe though. I think we might have made our own. The other one where we used thread RNG was... I know, and this is one thing I have is that if I do find in files. Yeah, the Great Dispatch, you're correct. The Great Dispatch would use it. And the Great Dispatch is really the older code, which is one file. And it has the RAN stuff in it, so good, that's what I want. RNG, and it has this random number generator. And I'll go throw that over here. We use it once for each iter best move. And this function is costly in Rust. And it is kind of bothersome because it looks to be costly in release mode as well. So their thread local variables do not appear to be using the correct system thread local variables. But I haven't checked this again. And again, we're using it as simply older version of Rust. So maybe they fixed it. But this looks up a thread one. It should almost be free. On a modern Linux system, thread local variables are essentially free. They shouldn't cost anything to look up. And to destroy them and manage them, that's another story. But simple lookup should be free because there is a thread pointer in one of the stack variables. Aim as stack. Yeah, that's the one. That's what I want. So I have a good reference there as well now. So thanks, Philion. And what do I want to use? I want to use this right here, range.gen range between 0 and, again, I'll try to use the grid width. State grid width. And the rotate, there's one of 4 rotations. There just is. And because I'm going to be a nice, correct, clean programmer, I'm going to do this hub const rotation count. I've been doing more interviews lately, and I bug people quite a bit about magic numbers, and it makes a lot of sense. The reason why you document these numbers is because when you're looking at this variable, and it's a lot clearer what this is. Even though we don't have a dedicated turn type, I have something to do with grid width and rotation here. Gives a much better idea about what I might be doing here. And a to-do here is valid. I should check this, because otherwise I might end up with absolutely no items in the tree, because applied turn is going to read and turn invalid ones. Or I have the option of saying apply turn. Yeah, let me think about this. Anyways, I apply this random turn. So all of these, so none of this makes any difference. I apply the random turn, and there is no recursion in this approach. I go through all the items, all the blocks I have. I check it, and then I do the score, and I enter +1. And what is the condition here? The condition is going to be time-based. For now, I'm just going to stick a value in. I'm just going to say, well, iters less than, let's do 100 evaluations in each one. Let's get hopeful, 100. This may not return because of this is valid thing here, though. So let's just do 10 for now, just in case we have that ability. And the search tree is, so I'm saying at the top point here, the get best search move checks for each of the columns. I could put the first one in. For each column and each rotation, I could put the first one in. We're going to score that option, score that state with the additional items, and for each of those I'm going to check 10 moves on each of them, and by 10 moves I mean 10 branches through the tree, score it, and then pick the one with the highest average score. And this is already a lot of moves, because this is 6 times 4, so 24 times 10 moves. That's 240 moves I'm going to evaluate. Oh, 240 board states, I guess, are moves, or no, only 24 I actually do evaluate, but I do a lot of turns. 240, yeah, never mind. 240 complete things. And I apply the turn for each of them. And this part here is a little bit broken. It's just not going to work. And this has to be step. But I'll see what happens. It's going to do something weird there. Did you mean, oh, we need to put rand in the cargo file? This is one of the things I don't like about Visual Code, is they're missing some UX, and they should do UX testing. Is when you open up the search facility, there's no way to close it. Right? You can't just say get rid of the search facility. I want to go back to my browser here, and I don't know how to do that. Oh, there it is. There's one there, maybe. No. View Explorer. So, if anybody knows somebody at Visual Studio Code, can you please put an issue for that? I'm not going to bother. I don't like it enough to actually want to improve the product, to be honest. There's just too many things wrong with it. But if somebody else wants to, they can. And I just use it for the show, so I distinguish it. I have a good branch from the other things. And it does a lot of wacky things I don't like. If somebody can tempt me to add all the issues, I would, but I don't have good history with these issues getting addressed. Alright, so I wanted the cargo tomo file, that's what we're looking for. And dependencies are rand equals star or something. And that'll build the rand file. I'm surprised I managed to do this. This is the first time I've added a dependency without having to look up the syntax. So in some ways I guess I'm learning something. And it downloads a whole bunch of other stuff. And I still have errors, but that's okay. Download self-rand, and yeah, this is where the weirdness happens in Rust. I don't like the way they structure modules. Somewhere here we stick the rand crate. Oh no, you can't put it at the top. Rust has a lot of issues with ordering files and stuff having to be ordered in the right way, and we compound this by combining them together, but I still don't like it. And then you use rand as well. And there's no parentheses here. Oh, I think it's pointing to the wrong one. That's okay. I'm fine with pointing to the wrong one. Alright, step should be... What is step? Isn't block count a use size? It should be. Blocks count, rotation count. So this should be a use size already. This doesn't make any sense. That should be a use size. No, it's clearly pointing to turn. Uh-huh. Okay, that's why. So it's... Which line is it pointing to? Alright, so this is here, rotation count generate. Oh, whatever, as I-32. Now let's see if I actually don't get a timeout now. Let's see if I can actually play the game at least for a few seconds before it crashes on me. Well, I do different stuff, that's for sure. But you can tell I'm not searching very deeply. The stuff is essentially random, is what you would expect. And I'm going to increase the speed of this here to 5 times because that makes it more fun. But I haven't done a very good evaluation. I'm not, there must be better options out there. Okay, good. So, and it could also be because of this validity thing. So let's do the validity thing first. Apply turn. I wonder what's the chance of that. I'm going to figure that out first. So if you have 2 moves and the 2 aren't valid, let's just not generate invalid turns instead. That would simplify it a bit more. And so the rules are that the rotations have... You have these 3 rotations. And this one and this one are problematic. This one's problematic in column 1, and this one's problematic in column 5. So, let's just clean those up. If turn.0 equals, and this is the column, I'm in the wrong place, ignore me. Right here. And I'll just do it this way. Let column equal... And let mort-ora-y equal this value here. And this continue here, it has to continue to this while here. I'm not sure how to do this. This should actually break, to do, and don't score. Although honestly, that's probably a decent score there. It just takes wherever it was now and it should be fine. Not that it should ever happen. So we have 2 conditions. If column equals 0 and rot equals 2, then we're just going to say rot equals, and I'm going to totally bias this. I just don't care. This does a slight biasing in the result set, but it's not significant enough that I'm going to worry about. Or if it's the last column and rotation equals 0, then I'll just set rotation equals 1. And this means we should always have validity, and this might allow us to evaluate more. Okay. What have I done? Oops. I don't think this will make a difference. I don't think we're evaluating enough. We're going to have to put the timing on right away as well. I don't have to put timing code in. We've done timing code before to time. This loop would ideally be based on time. Let me just check with 100 first instead. Oops. And hope we have enough time for that. If 100 doesn't work, then again, as I say, that's a problem. No, so 100 doesn't work, so that's already a timeout. I'm also doing the scoring wrong, just so we haven't forgotten that. The scoring doesn't take into account the chain reactions yet. So let me check this first. Can I actually do 50 of them? Now this is already pointing to us having big issues with this. And I'm going to see the progress we can make today, but if this is going to be the issue, yeah. Because 20 sucks. 20 is not enough to get a fair bias of what actually that result has. It'll do absolutely nothing for us. It detects at least a little bit, but it's not detecting combinations, and I got a timeout here anyway, so it's already too long. At 20 being too long, it's like you can already see my frustration with this. That again, back to this one here. Please enable release mode. Again, we're not optimized yet, but in debug mode, just everything, even the simple stuff, goes slow, and there's only so much you can optimize. So this may have turned out wrong, but let's at least finish the calculation for how we destroy it, how we score the board here. Destroy groups, and let's just do it this way. Let's score it. I'm going to make a very costly approach first. I'm going to call it score mutt, on the understanding that this board, no, let's just call it destroy groups. Let's call it, what am I going to call this? I want to destroy the cells. I want to clean up the score. I want to destroy groups and progress, and I'll just call it advance. Give a duplicate of that. And it's going to take a score out of that. Let's advance score. And I have to take into account. Now, this is another one of the stupid things as an editor. Who in their right mind designs an editor that when I press up key here, it gets stuck in that location, right? That was just really bad, and whatever. So advance, and I'm going to destroy groups. Where was that? Destroy groups. I need a function called advance now, and this is going to destroy groups and then do more. This should probably be an F64, but let's just do it this way for now, and just do it like this. Just do a loop. Let gone equal destroy groups. Give it the state. If there are none gone, if we haven't destroyed anything, then we can break. Then we're done with this. There's nothing left to destroy. Let total equals 0.0, and then we just return this at the end. No score on that one. And if the groups did get destroyed, let me fix the spelling first. If there have been destroyed groups, then what I have to do is drop, what did we call, did we give these things a name ever? Drop blocks. Yeah, drop blocks on state. And this will go through and find all the places where we can drop blocks and just simply move them up. Again, it's going to be a little bit costly, but I can do that. And the drop blocks function, alright, total has to be total plus equals gone as F64. I'm going to take a quick look at the scoring to figure out how they do scoring so we can actually get a slightly better score. Scores are calculated as follows. The number of blocks cleared in this step. So 10. Wonderful. That's good. And there's colors here. So unfortunately, I'm going to have a hard time tracking colors. Alright, so we're going to have to calculate a few things. Chain power is, and that's what we can do, chain power. So let mut chain power equals 0. Chain power plus equals 1. Okay. And total is the B, the blocks. I need to know the number of blocks. Let mut blocks equals 0. Blocks plus equals gone. Those are all the blocks that are gone. And the formula then says, I mean, there's 10 times here, but this is kind of pointless if everything's 10 times. It's because they tend to calculate in integers. I'm just going to leave it as that. So blocks times chain power plus, what else do we have? Something else. Chain power and color bonus. Color bonus equals 0. I don't care about it. We're not calculating this yet. We have to figure that one out to do. And what else do we have? Group bonus. And these are to figure out. We can figure these ones out later. These are definitely bonuses to getting these things. And they'll help the scoring a lot. So color bonus. Now I'll just do one at a time. See if it helps. Anything at all. But I need to write the drop blocks function first. Function drop blocks. And mut state. This could, as an optimization, actually return a bool, because if nothing's actually dropped, but for now I'm just going to do this. So for x in, for each of the columns, grid width, I'm going to start from the bottom and look for empty cells. I hate doing such for algorithms. They're really, really simple. You start at the bottom of the grid and you count up. If there's one there, you keep going. And as soon as you hit an empty one, you stop there. And that's the first place to put it. And then you keep scanning upwards until you find one to drop to the bottom. So you actually have 2 counters in here for each one. You have mut put at equals state grid height minus 1. This is where the next item is going to go. And then we have a y for in 0. No. I have a hard time doing reverse iteration in Rust, so I just do it for grid height. Go up to grid height. And I'll just call this IY and then say, if it remembers, so y equals state grid height minus IY minus 1. If anybody knows how to set this up in Rust correctly, I'd like this reverse iterator. I don't know how to do it correctly. We've tried it before, but it's always this minus 1 in the end state that gets kind of annoying for us. If there is a block at this state, let block equals state.grid.getXy x comma y. If block is destroy blocks, we also have to kill skulls. So let's not forget. Let's put a to-do up there. I'm just going to forget about that. Destroy group at. Destroy group at. To-do destroy surrounding skulls. This just makes it slower, by the way, which is a real pain. And if block is greater than or equal to 0, then I'd put this in the next place. So state.grid.setXy x comma put at the block. We move it down. Then I say put at plus equals 1, and I clear the current one. Grid.setXy x comma y minus 1. Our magic number is saying there's no block there. And that should move all the blocks down 1. For each of the rows, drop blocks. And it's supposed to be an as F64. Okay, and blocks is supposed to be as F64 as well. And all of those up there. As F64, as F64. Alright, now, lacking test cases, you should really create these things if you're creating proper code, but I just want to see graphic tests. Alright, I get it. This is why you do test cases, so you don't, in a competition do this. Index out of bounds, and where did I do this index out of bounds? I had screwed something up somewhere. Where is it? And set xy and 223. This is a bit of an issue in drop blocks because we combine the files. I don't know. I could look in the file, but I'm just going to guess drop blocks. It says there we have an index out of bounds in drop blocks. The x is fine. The stated grid height here is fine. And oh crap, put at has to be minus 1. We're going up the stack, not down it. Calculating longer, which is a good sign. Hey, we won. Did we just get lucky? I don't see us doing any combos. Like, I do no combos here. How could I have possibly won? I think I just got lucky, to be honest. I should keep replaying the same one. Well, I mean, that's a good sign. In the words of Ragnakas, one of our viewers, submit, as he would usually say. Just submit something. I'll let that run out a bit. I'll just check the messages or wherever's on my phone, and I'm not doing well there. So let's just find out what happens. And okay. And I won't mention what my messages are about. They're totally inappropriate for a live show. So it looks like I'm not doing well. I'm under 1,000. I mean, I could be doing worse, but these could all be from people above me. So let's fix a few things first. Let's get the scoring right, and then figure out the optimization. But if I get the scoring right, I'll just leave it with that. The optimization I'll worry about later, because the biggest issue with Rust in debug mode is that it's kind of pointless to do any optimization, because even if you get algorithmic optimization, it's just still so pathetically bad that the simply release mode gets you such a huge gain in comparison. Now what I really need for this show is to find a way to put this thing up here to keep running while I keep looking at the code. I wonder if that's possible, how we could do that. But it also has, oh, I can't, no, I can't do that anyways because this has an actual issue. If you're sitting here, you get a massive out-of-memory error, so I have to close this anyways. I reported that as well to Coding Game. So what do we have now? I'm going to drop blocks. Let's ignore the skulls first. Or skulls, they may or may not be important. Skulls probably count towards negative score. The more skulls you get rid of, the better. But destroy groups. What were the other scoring criteria? That's what I want to look at now. What are the other scoring criteria? Color bonus, depending on how many different color blocks were cleared in the step. Alright, so destroy groups should give us colors, I guess. Colors, that makes sense. Color gone, comma, colors. Good enough. Destroy groups, gone is going to return this. Now, I don't like such tuples. I don't think you can name them inline. I'd like to have them named inline. I don't know. It's quick to type alias. For now, I'm just going to say gone colors. That's fine. Gone. Let what colors equals 0. Gone, comma, colors. And for simplicity, I'm going to go over to destroy groups wherever we call it now. It's called in this place too. Get destroy move. And I'm just going to simply drop this out because we don't use this right now anyways. Just be very clear, get destroy move. See, it's not even called, so that's fine. I'm just going to comment out the whole thing then, perhaps it's cleaner. Just comment out the whole thing. So destroy groups returns 2, and it needs a color. Destroy group at. Now what does destroy group at do? This is where our stuff gets really super costly, but that's why I have it wrapped so that I can find a more effective way to do this later, and there are much more effective ways of calculating this board. But what do I have? Get, group len, linear set. Destroy group at should return the count and the color. Not the colors, just the one colors. Let g, comma, color equal destroy group at. Gone plus equals g. Then I had to figure out something to do with the colors then. This is going to be awful. Let's say this is a hash set. This is going to be ugly. By ugly, I mean slow. Colors.insert color. And then colors.len. And this is 0, 0, doesn't matter what the color is. If g equals 0, then we continue, so it didn't do anything, so I don't add them, that's correct. Group.len is I32, and group... The hell did I say group was? Group 0. That's a linear index. State.grid.get. Oh, I should actually get the color before I destroy the stuff. That would make sense. Color equals state.grid.linear.get group 0. And that's the one color there, and then we return the color. number of blocks, and the color, and that's the color we're getting from the grid. Because getGroupAt returns a vector of the groups, and this is why it's super slow, because we're creating these vectors. And again, we do have really clear ways to fix up a lot of this, but a lot of that doesn't make a difference because it's not actually these allocations that are so bad. When we did the profiling in the last thing, we found it's anything to do with iteration. The iteration, like the for loops, like this stuff here, are pathetically slow in debug mode in Rust, and it's not a failure of Rust, it's really a failure of Coding Game not supporting release mode, because in release mode these are free. It doesn't cost anything as you'd expect. Okay, it costs the increment on the chip, but there's no overhead to these. There's no actual overhead here, whereas in debug mode there's a significant overhead. And we discovered that by actually rewriting these groups, but I'm not going to rewrite them because that encourages bad coding style. But let's keep going. So we have getGroupAt, getColors. What did I just change? Colors. So everybody's colors, insert colors. So now destroy groups returns colors as well. And so I can say color bonus. Well, let's just say colors. Let's move colors. Oh, this is going to be a pain though. Because it's the total colors. All right, so I have to backtrack out of this. Colors is a hash set up here. Get rid of this here, let gone equal this. And I'm going to give it an add mut colors. Going to pass in the colors. And I'll figure out down here what this is afterwards. Destroy groups takes a hash set. Colors is a hash set. And there's a much cleaner way to do this than a hash set if we simply have a little vector of 6 that says the number of colors, and that would be a lot faster. And actually, to be honest, let's just do that right away. Except I don't know if the square ones count. Let's just do a hash. Let's do the logical way first. Hash set I32. This is a mutable hash set. A mutable hash set. Let's do colors insert and return gone at the end. Don't have that. I32 and gone, like gone equals 0. I32. Destroy GroupAt, it gets a color insert. Okay, so we have all the colors. And how do we evaluate the colors? This is, well, this is a special case. 0 is a special case where you get, one of the colors you get 0 points, 0 point extra, and the other ones are 2, 4, 8, 16. So it's to the power of 2. So that will be let color bonus, and I'll ignore the 0 case for now. Colors.len as f64.power, no, it's actually as 2.0.pow. And this notation looks awful and I don't like it. And this is really colors.len equals or less than equal to 1, then we get 0. Else we get that. Color bonus is an F64, so that's fine. Plus the color bonus, and I don't have a group bonus. Let's see if this compiles. I made a lot of little things in there. And this is incidentally an inconsistency in Rust syntax. If you're declaring a type, you don't have the colon, but if over here you have to give a type, you do declare the colon, and it's an inconsistency in their syntax. There's not much I can do about it. Alright, this one's going to go away as well. Just going to comment it out. We don't need it. Probably never going to go back to it, but I feel like getting rid of it for now. Alright, what do we have? Gone. Oh, now this is curious as well. This appears to be another inconsistency of Rust I've never seen before. Why can't I do this? Destroy groups returns a tuple of 1. Why can't I unwrap it here? It's these types of inconsistencies that in Leaf I'm really trying to clean up on, because they actually bug me. I mean, if you can do gone, comma, color, you should be able to do gone the exact same way. And the problem they've done, and this is something that is the issue, is that when you overload the parentheses operator to mean both tuple and an evaluation, like whereas an evaluation is right here, when you overload this, the language has no way to properly determine what you want. So as best as I can tell, what Rust is doing is that the moment you have a comma, it understands you have a tuple. But if you don't have a comma, it's more than likely saying, oh, this is just an expression. And I don't like these types of inconsistencies. They make the language hard to work with. And that means I actually have to remove it. So you cannot have a tuple of 1. You cannot effectively use a tuple of 1 the same way you use a tuple of 2. It has an inconsistency with it. Alright, what do I have here? Oh, I need an if. I'm going to get the if statement. Power, anybody know how to do the power function exponent, maybe? No, exp is usually to the power of float, Rust power function. Well, this is a reasonable one. Well, there's apparently a pow function here somewhere. Pow. Or not. Where the hell is pow? Oh, this is wacky. Why the hell is there a pow-f and a pow-i? Oh, I know why. Because, yeah, you can't overload functions. And so you get, Rust then ends up with these same types of things, the old C convention, which I think really sucks, that you have C, when you're dealing with different types, you have stuff like pow-f, pow-i, pow-l, pow-c. It's a real pain to work with. It's the type of thing that overloading was meant to resolve. And there's no way I think Rust can actually solve that overloading issue because of their type inferencing. So it is a nuance in the language, and you just have to remember that. But it's still, there's still no pow-f for type float. It says it was there, F32 pow-f. Of course, it's not in the docs, so the index listed it, but the docs actually don't list it. Anybody know how to raise a power function in Rust? There's something weird here. I don't know how to do it. I can't figure out how to raise a power to function. Do I have to import something, or what the hell is the issue here? It says and it's referring to a braced float type. I don't know if that's just the way it writes those things. What the hell? Alright, that's something I wasn't anticipating. And this is something I think is also another inconsistency. Why does 2.0 is supposed to be a floating point, and 2.0 I was told was the same as 2.0 F64, but it clearly is not. 2.0 is not the same as 2.0 F64, which is a surprise because I thought it was. and so I guess it's different. And this is what I say, this is what Rust's type inference system fails in so many cases that I actually don't like it. I would prefer to have a simpler type inferencing, because you're ending up having types in so often in weird places that I don't think it really helps as much as they'd hoped it would. Alright, so now I have the color bonus. Is that enough to give us a fighting chance or not? Otherwise we'll do the group bonus. It's taking a while to calculate, which is a good sign. It means we played a long time. And you can see I never set up any sort of long chains, and Euler, I honestly don't know. There's some sort of weird inconsistency in the language that 0.0 is, sometimes it works and sometimes I guess we found a case where it doesn't. I'm really unsure on that. It makes no sense to me, because right here I have a 0, 0, and that works, but right here we can't have that. So I'm going to throw up my hands. If somebody wants to ask the Rust community why I can do that, maybe I can put a 2 here. Why is 2.0 F64 required? It feels like an inconsistency, and I'll put it to do. Maybe if we can follow it up at some point. Okay. Now, one of the issues I have here is that if you notice the way I'm calculating it, I'll play another game. I'm not waiting for combinations. Right? Look at those ones right there. There's a green one and a green one coming. Our scoring is going to say, well, let's evaluate through all these things, and it may not find a more valuable way to use the green one, because we're not evaluating enough of them, because it says, well, putting the green one here, that gives us points. And there is another case that would give us a lot of points. If we put this green one right here, and then on this third green one here, dropped it down here, that would give us the most points. But we're not finding that solution. I'm just ignoring it. Therefore, I'm taking the simple one as dropping it on top. Same with the yellow one. If I can't increase the number of evaluations that searching does, I don't have a chance. It doesn't matter how much I improve this group bonus. I just don't have a chance. The one way I could fake it is basically say, just don't take cheap combinations. Just set the board up and just don't do combinations that are small. But that's not so much fun. So what else can I do? So it got up to 711, the one we're right now. Let's check the other bonus. Make sure I'm calculating that. Alright, and so each group gets a bonus. And this bonus is significantly large. Yeah, this is a really big bonus. Number of blocks times the bonus. So higher block scores are worth a massive amount more. It's not just a linear amount, it's more of an exponential amount. And let's build that one in then. And this is for the bonuses of all groups are summed up. Okay. So where's destroy groups? This is gone right here. I can do it right at this level here. Alright, and this is very clear, gone. And there's a gone bonus, a group bonus. I'll just do this. No, let group bonus equal gone -4, it looks like. Gone -4. The maximum is 0 to the minimum of 8. And I can actually just do this in my group bonus plus equals. Destroy groups, however, is actually wrong then. Destroy groups. Ah, right. Destroy groups has to return a group bonus. Sorry. I just can go group bonus. And so now this can return 2 I-32s again. Group bonus. Group bonus. And gone chroma group bonus. So we collect the group bonuses and they're all summed up. That's what it said. The instructor said all the group bonuses are summed up. And so I sum it up here as well. And that gives the group bonus 64. And that gives us a significantly improved value of groups. If I happen to find one in my evaluation, then great. If I don't, then I'm out of luck. I don't use total. This immutable group bonus. So that's our scoring now. Just don't need total. I highly doubt this makes any difference, but let's try it anyways. It made a difference, but I might have gotten lucky. You just never know with these things. Because I am not doing anything clever now. I'm just destroying simple combinations. That's just not clever at all. Whatever algorithm the computer had just sucked in this case, and right, then I'm gonna submit this anyways because why not? Let's roll with it. Does this give us enough to get anywhere? That's the question. Well, what does this give us? Do I get higher? I have the same number of losses and wins. It's like there's top guys, but a few less losses than last time. So I have all the scoring, and then there's the timeout. Now, let's let that run, and let me explain the next issue here is the Monte Carlo thing. I have one thing I don't consider yet. I don't destroy the skulls, but I honestly think that's not going to make a huge difference in the evaluation. It might, maybe not. Right, the destroy surrounding skulls is right here. Might that make a difference? I don't know. And the next question is get best move search. This explores all of the possibilities of all the things we can do with the top level moves. What works, that's fine, and take the one with the best score. Okay, I can improve this for the Wood League at least, and just say up to 2, because the colors match in Wood League. This gives us twice as many evaluations we can do. And that I mean, because the rotations, because it's always the same color, won't make any difference. But the inner best move now is an issue that this is all fine. I can increase this to maybe 20. Let's see if I can go all the way to 34. And this triples the number of evaluations we do. And let's see if it actually helps any. Of course, I've already beat him before. So I should beat him again. If I don't beat him again... Okay, but we have a lot of randomness. That's a problem. Yeah. And look, we already timed out. That's not helpful. It's going to be rather pointless for us to go any further on this one with the debug mode, because as Euler just all pointed out beginning with, it's always it's so bound to the release mode, the calculations thing, and you know what, like the way I calculate what happens when you apply turn is really bad. It's not efficient. But the thing is, I'm dealing with a count of 10 right now. I do 10 or 20 evaluations. It's unfathomable that I have to get up to like 10,000. That requires quite a big improvement in the algorithm, theoretically. And so I just don't think that's going to happen. Unless I can think of something simple, what is actually going to happen when I do that? And you cannot profile these things in debug mode. Profiling in debug mode is kind of pointless because it's just going to be these iterations. You're not actually going to see our code. You're not going to see like what the significance of my code is. You're just going to see that. Alright, so I'm going to take Euler's comment here and do ghost in the cell next time. If we stop doing this one now, we can do ghost in the cell next time because heuristics, you have lots of time to do basic heuristics. We still have the issue with iteration, but it's okay, and as number states, that's good. And I'll take his word for recent top in heuristics. And what I mean here is that when I say our algorithm's slow, is I don't mean this outer part here. This get best move search where I iterate through all of these. And all of these moves, this has to be done. I cannot skip this stuff. This has to be done. In order to figure out which of my moves is the best, I actually have to look at all of the moves. Otherwise, it's kind of pointless. So this outer loop, there's nothing that can be done here. This cannot be improved. Then look at this inner loop. This inner loop here, for each one of these things, we have to clone the states and then apply to the bottom. We go through one of the moves, and this here itself cannot be improved. There's nothing to be improved here. This iteration here, one thing that can be improved here is this apply turn and the state clone. The state clone, as I found out in one of the previous streams, cloning in debug mode is shit as well. It's really bad. It does really bad things, and we can improve that. But as I did the release testing, again, in release mode, the cloning was not a problem. So it's kind of a pain. There is a clone from that can improve it a bit. But again, when I looked at the performance last time, it wasn't the cloning. We suggested, some of the viewers said, thought it was really cloning was going to be a big deal, but the memory allocation wasn't. It was just all iteration stuff. Iteration, 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 iteration. And that means the only thing I can do is assume state clone is fast enough and then look at apply turn. Sure, gen range is also slow, but I'm not doing that often. It's apply turn is most likely the one that has the issue, because apply turn, fine, this does two things. There's no choice but to do this bit. I apply the turn in 2 blocks. And it may not even be apply turn that's slow. It could be the get destroyed blocks. So I apply the turn and apply turn block, and it's actually, this one's probably fast enough. But as I saw in the last game when I was doing performance testing of this, the grid, these matrix functions are terribly slow. Extremely, horribly, awfully slow, and this because of debug mode. In release mode, this basically goes away. This becomes a very simple multiplication and assignments, but in debug mode, slow. So the next step is destroy groups. What do we have for that? Destroy groups. So advance. Advance is now the case where it could be questionable. The loop can't do much. This hash set here, this kind of sucks. Yeah, it's a tiny bit of it. The next question is destroy groups. Drop blocks. Well, that's a curious one. Let's check drop blocks first. Drop blocks, I don't honestly think you could implement this another way. You have to test all of these modes here. But when I did the performance testing on Hypersonic, I saw that this type of iteration was extremely slow in Rust. Again, in debug mode. I'm not bitching about Rust right now. I'll reserve my complaints about Rust. I'll reserve for proper complaints. This is just about us being forced to use debug mode. And so that means there's no way I can optimize this. I mean, I shouldn't optimize it. I know how to optimize it. I figured that out last time. If I inline all the stuff, it will be extremely faster, but I shouldn't have to. This is the clean code. This is the code that does the proper iteration, and so I shouldn't actually have to optimize that. And that leaves destroy group. And destroy groups is a really bad function. This is the one that algorithmically is really, really, really bad. But, again, maybe not. Because destroy group, you do have to check every bit in the board. It's this destroy group at which is kind of the issue. Destroy group at figures out what it is. The best way I can think here is that if I had an optimized algorithm to look at the board just once and find all the groups that have higher ones, but that might be clever, and so I'd have to do that one actually offline to think about whether there's a faster way to find all the groups that are destroyed. And here again, though, there's going to be a massive overhead from the debug mode Rust, because the get group at, you see we have this hash set, we create a new one, and we return a vector. These creations are really slow, and we add the open, and this is an A star, and this A star is for every single place in the board. We scan this, and, oh sorry, this is flood filling. Now, flood filling isn't supposed to be slow, and this is why I'm really concerned here, is that we're going to be fighting around the fact that this stuff here shouldn't actually be slow. Hi, Woody Prakash. Welcome to the show. We're currently complaining about the fact that we have to compile in debug mode, not in release mode. Because if you see this code here, get group at, this is like a lot of code, and you're thinking, whoa, this is like, hey, flood filling is expensive. And it's like, but it's really not. Flood filling can be extremely cheap, but not if iteration stuff costs a lot, not if you're using actual vectors, open found and stuff. And I could actually reuse all of these things, and this would help a lot. But I don't want to blindly start doing that, because I don't know for sure if this is the problem. And if I ran the performance testing last time, I just couldn't test it. The profiler was all over the place. It's impossible to pinpoint what the problem was because of the debug mode. And so I'm really tempted to just say, like, look, I don't want to optimize this now, because while there may be a fundamentally better algorithm for doing this part, this isn't awful. Woody Prakash, we're using Rust right now. So I always do the show in Rust. And the problem is that Rust in debug mode, because Coding Game compiles everything in debug mode because it likes to. And that's causing us a huge problem for optimization. And in games like this, we require excessive optimization. And I'm not willing to rewrite the code to work around debug mode, because I tried to do that last time, and you start getting really, really ugly code. Eventually, I will have to rewrite this, but I don't want to do it right now. Because again, last time I said this visited set. This visited set can actually be a bit set. I know the entire board can set in 128-bit integer, and this might be a platform problem, or 264-bit integers. And so we know that can go away, and open and closed. Yeah, I'm doing this one. Prakash, I can show you run it again. I'm doing the competition. I'm the guy on the left here. And we have to drop these things, and the bigger combinations we get for the drops, the more damage I do to the guy. And you can see my algorithm is very basic. And it's basic because I can't evaluate enough. I'm just checking random stuff. And I'm doing sort of a Monte Carlo sampling to figure out what is my best move, and I just don't evaluate enough options, therefore I fail. I just can't go through enough, and the Wood League, I'm going to have to do more than that, and I'm looking for ways to optimize that don't involve defeating the debug mode. So the biggest option I have is to refactor get group at. the next step is to, yeah, but I know from last time, these functions here are just so awful. So awful in debug mode that it's almost pointless. Even if I reuse these values here, it's just not an easy way. I can think offline if maybe there's a better way to do this, but unfortunately I can't do it live, and unfortunately I don't think that's the big issue. So this debug mode thing, and again, I've been fighting this debug mode thing a lot in a lot of the games, and it's getting kind of tiresome to fight the debug mode because I want to keep the clean code. And this one, as Euler Chisal pointed out at the very beginning of the program, the show today, that this one is so dependent on depth searching. I mean, you have to be able to evaluate in the future, because otherwise I resort to heuristics, but I can't even resort to heuristics. That's what the funny bit is. I am evaluating so few board moves that I wouldn't even be able to build proper heuristics. And that's because, mainly I think because of this flood fill. This is a flood fill. This is a flood fill, just so we know this is a flood fill. At every spot in the board is extremely slow. And I do have one way to improve this, and I'm going to think about this offline. If I do figure a way out offline, I'll keep doing this one next time. Otherwise, I'll move on to Ghost in the Cell. Is that there is a way to flood fill everything on the board at once. Whether I can figure out the size of those groups or not from that is another question. I just don't know about that. So I'm going to find out whether I can actually do that. If there's a way to do the flood filling, I will. Otherwise, I'll just move on. And if I can find a clever one, I'm sure there is a clever one. And that is to flood fill everything on the board at once, rather than doing the destroy groups rather than iterating through. Just do one flood fill that identifies everything on the board at once, and then destroys them all. I'm pretty sure there's a way to do that. This type of algorithm I can't do in the show. So for now, what I'm going to say is I'm just going to leave this for now and git status, git commit, extend scoring. So we have the correct setup for doing this. I have the loop at the top, which does the move search, checks it, and then does a simple sampling of the potential moves and the scoring. But without this number here that's at 20, just for reference, and why I need release mode is this number doesn't have to go up to 200. This number has to go up to like 20,000 or 200,000 to do good. And this type of performance optimization requires release mode, because the types of optimizations you do in release mode are completely different than what you do in debug mode. There is one algorithmic one that would help a lot. I can do that offline, but still, we're going to hit that fundamental problem about release mode. So I'm going to leave it at this for now, and sorry I can't give you a longer show today, but I'm not going to sit here and be frustrated with it like I was last time. And I'm going to leave it like this. If I do not figure out the way to do this algorithmically, then next time I'm just going to start with Ghost in the Cell, and that'll be next week. I'm going to try and stick to my normal schedule now of Evening Rust to be Wednesdays starting at 6 or 1800, and Thursdays starting at 2100. So I have a bit of a regular schedule, and I cover 2 time slots. Hopefully you guys can watch a bit more often if I have a regular schedule. And I might start up some of the animation streams again. I'm talking with some of the guys in the Fuse Open community now if I do Fuse animations. And I might start a new graphics tutorial show next week, but I haven't figured out when I do the Leaf show as well. So please just make sure you follow me on Twitter and on Twitch. I always announce on Twitter in advance when I'm going to do stuff, and that's the best way to find out. And even though I may not have a fixed schedule, I'm going to have regular times set tight when I actually do stuff. So thank you very much for watching, and we'll catch you next time.